Okay, so I wanted to start a video, kind of extended video for students that may be struggling a bit with stuff they picked up third quarter. So, in order to name ionic compounds, you need to be able to understand how atoms form ions, and you need to be able to figure out the charge. Um, that is sort of a roadblock, and so I just want to do an extended video for students to review that. So, there's a lot of different ways that we talked about it. So let's start with the whole why of it. Why do atoms form ions? Okay, we talk about it in terms of reactivity. And we did some experiments during third quarter to look at calcium in particular, right? We compared calcium and magnesium, and we found that magnesium and calcium are very reactive, and calcium was more reactive than magnesium. One of the reasons why magnesium and calcium are very reactive is because they're metals, and metals have this tendency to give up electrons. So when we're looking at chemistry, we're studying matter, but we're also studying change. And when metals change, they form ions. They lose electrons. Sodium loses electrons. It's explosive in water, right? It just wants to get rid of those valence electrons really badly. And we talked about it in terms of what's called ionization energy, the energy required to remove an electron. Okay, and it's really easy to remove an electron from elements that are in these first two columns on the periodic table, these metals. So let's take a look at sodium, which blows up in water, okay? So sodium has a certain number of protons and electrons, okay? It has how many protons? Protons are always read from the atomic number, 11, right? So 11 protons. Okay, how many electrons does it have? Well, if we're looking at the periodic table, it's always the same number of protons and electrons. All right, all of these elements are what we call neutral. So if I have 11 protons and 11 electrons, protons are always positively charged, electrons are always negatively charged. Negative 11 and positive 11, the overall charge is 0. Okay, so let's take a look now at chlorine. It's not the periodic table I want to look at right now. Okay, so chlorine is over here as atomic number 17. 17 is the number of protons. That is not the document. Here we go. All right, so it has 17 protons and it has 17 electrons. Negatively charged, positively charged, 0. Okay. So what makes sodium so special that it wants to give up electrons? Well, let's look at how many electrons sodium actually has. All right, so it says it has 11. Okay, when we look at atoms, and we talked about this during third quarter, we talked about energy levels. Sodium has energy levels which we represent in rings. Okay, the number of energy levels an atom has corresponds to the row on the periodic table. Hydrogen, for example, has 1 proton and 1 electron and 1 energy level. Okay, the first energy level holds a certain number of electrons. 2 electrons. 1, 2. Okay. Okay. So that's one row. First row, first energy level. Okay, let's look at the second row. The second row, we add another energy level. Okay. Now this energy level is further away from the nucleus, and therefore it has a larger diameter and it can therefore hold more electrons. So in addition to the 1, 2 electrons it can hold, it can also hold another 6 for a total of 8. 1, 2, 3, 4, 5, 6. Okay. Now I'm going to go out to the third energy level. Okay. Third row. So if I add another ring, okay, now I can have the same number, 8 electrons that I had before. Okay, 1, 2, 3, 4, 5, 6, 7, 8. But now it gets even bigger, right? So we can actually hold another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So as we go out, each ring, each energy level, we give that a letter called an orbital, right? So the first ring has one energy level, one orbital, that's S. The second one has S. And then it adds, whoa, sorry, P. So S holds 2, P holds 6. That's how I get 8. Hopefully this is a review. So I get to the third level, I have S, I have P, and I have D. D holds 10, okay? So the further out, we add more and more energy levels, okay? So sulfur has a total of 11 electrons. So let me get rid of all of these guys on this third ring, okay? Because that's just the maximum it can hold before we go, right? And it's on the third row of the periodic table. Oops. Got a little crazy with the eraser. Sorry. Okay. So I don't fill the D, right? So let's count how many electrons. Remember, I had it on the other screen, it was 11. So I'm just showing you guys how it grows the further out you get. So I started with 2, 1, 2, S and P, right? So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? That's the maximum it can hold. And then I had one more. All right. That gives me 11. Now, let's take a look at another atom. I'll do it right next to it. Let's look at neon, which is a noble gas. We know that noble gases don't react. They're stable. So let's take a look at this. Neon has the atomic number 10. So it has 10 electrons. Sodium has 11. So if I'm filling this in, right, I get to my third ring. So I have 1, oops, I'll do it right out here so it's a little easier to see. 2, 3, 4, 5, 6, 7, 8. Right? How many more? 9, 10. Okay. So I never fill this third energy level. I just fill these two. Sodium has a very low ionization energy, the energy needed to remove an electron. By definition, metals and nonmetals each form different types of ions. Metal loses its valence electron, and forms what's called a cation. So the valence electron are the electrons that occupy the very outermost ring. So if we look at sodium, it has just one valence electron. If we look at neon, right? Oops. If we look at neon, it fills up to the first two rings for a total of 10. So it has 8 because we only count the outermost ones, right? So anytime an atom has 8 valence electrons, we consider it to be stable, okay? When sodium forms a cation, it loses an electron. So it loses this electron here on the third energy level. Guess what? Now, sodium has the same number of electrons as neon. It has lost electrons. They both have a total of 10 electrons. They both have a total of 8 in their outermost ring. Okay? When sodium loses 1 electron, it has 10 electrons, right? How many protons? It still has 11. It's not going to lose protons because those are in the nucleus. Positive charge of 10, negative, positive charge of 11, negative charge of 10. Overall charge of the ion becomes +1. Okay? +1 charge, same number of electrons. So that's why it explodes in water. It's very reactive. It really wants to get rid of those electrons so it can become like neon, stable. Because now it's not going to form any more reactions. All right. Let's take a look at another one. So this is the why of it, right? It's about becoming stable. There's another piece to it. We'll talk about that in a second. All right. So now let's take a look at fluorine. Fluorine has atomic number of 9. So it starts off with 9 protons and 9 electrons. I can drop 2 in the first level, and then I can drop 7 in the second level. 4, 5, 6, 7. It's got 9 electrons. Okay. How many valence electrons? 7, right? Because we just count the outer ring. Fluorine is what's called an anion. It's a nonmetal, so it's going to gain an electron. Why does it gain an electron? There's one more. 8. It's full. So now I have 10 electrons, right? I also now have 8 valence electrons. Still have the same number of protons, which are 9. So if I have 9 protons, right, 10 electrons, negative 10 and 9, overall charge, -1. It's all about becoming stable. Cations and anions are trying to become like these noble gases. All right, so that's the why. All right, the next video is going to be the how to figure out the charges. All right, good job.